Okay, so now we're going to discuss case 2 of integrals that needed to be solved by using trigonometric substitution. So we talk about case 2. So for case 2, we will discuss integrals that involves non-algebraic expression like x squared plus a squared, x squared plus a squared. You take the square root of that, and so forth. So when we see something like this, we will have to find the trigonometric substitution. So the trig substitution is it's going to be x equals to a times tangent theta. So when we get x to be a times tangent theta, we will then find dx, which will be a times secant square theta and a d theta. Now, with respect to the trigonometric substitution, if you divide both sides by a, you will get tangent theta equals to x over a. So we're going to use this to draw our right triangle. Now the right triangle is this. We're going to use this angle is theta. Now we know by definition tangent is opposite divided by the adjacent side. So the opposite side is x, the adjacent side is a. So that means using Pythagorean theorem, we can find the hypotenuse by squaring x, add it to the square of a, and then take the square root. So hence we have a right triangle. And we're going to use the right triangle in order to change the theta expression back to x expression. So now let's take an example. So example on case 2. And that example is problem number 1. It says to integrate 1 over x squared times square root of x squared plus 4 dx. Now for this problem, you can see that we have if we compare with case 2, we can use x squared plus 4, square root of that is consistent with x squared plus a squared, then square root of the whole thing. So when we compare these two expressions, we can then let a squared to be equals to 4. That makes a to be 2. So now that we got a to be 2, then our trig substitution is going to be x equals a times tangent theta. Since a is 2, then it's going to be x equals 2 times tangent theta. Now, anytime you get x, then you should find a dx, which is 2 times secant square theta d theta. And if you build your right triangle with respect to the trigonometric identity, so then you know tangent theta equals 2x over 2. So hence our trig, our right triangle is going to be x divided by 2, x over 2, meaning x is the opposite side and then the 2 is the adjacent side. So hence the hypotenuse is going to be x squared plus 4, and then this expression is under the square root. So now that we get this, we go back to the integral, we can see that we need x squared. Okay, so we need x squared, and then we need a square root of x squared plus 4, and we need a dx. Now, when you look at this, we already have, dx, we have x, and we need x squared. So to get x squared, we're going to square 2 tangent theta. So that will give us 4 times tangent square theta d theta. So now we got x squared. So when you go back to the integral, we also need a square root of x squared plus 4. Okay, so to get square root of x squared plus 4, we have square root of x squared plus 4. Since x is 2 tangent theta, so you're going to have a 2 tangent theta squared plus 4, and everything is under the square root. So now, when you square 2, you get 4. You square tangent, you get tangent square, and then plus 4. And here, we can factor out 4. And then when we take the square root, because this is a product, so you take the square root of 4 times the square root of tangent square plus 1. So you get 2 times. Now, tangent square plus 1 is what we call secant squared theta. So we use the fact that 1 plus tangent square theta equals to secant square theta. So then when we take the square root, we get 2 times the secant theta. So here's the expression for square root of x squared plus 4. So now let's go back to the integral. So we go back to the integral, which is the integral of 1 over x squared times the square root of x squared plus 4 dx. So let's do the substitution. So we get 1 over, now x squared. So you get x squared to be 4 tangent square. It's right here. 4 tangent square theta. So we write 4 tangent square theta times. And then it says times the square root of x squared plus 4. But square root of x squared plus 4 is a 2 secant theta. And now we go to dx. Now dx is given over here. So dx is 2 secant square theta d theta. So dx is 2 times a secant square theta d theta. So now we went from x integral to theta integral. Okay, so now it's time to solve the theta integral. To do it, we can simplify. So here, we can simplify 2 with 2. We can simplify 1 secant x secant theta. And then we collect what we have. So 1 over 4, since the 1 over 4 is a constant. So you get 1 over tangent square theta, and then times secant theta d theta. So then we look at this. We can see that for us to proceed, we need to change everything in terms of sine and cosine. So if we know that secant theta is 1 over cosine theta, and then tangent theta is a sine over cosine theta. Okay, so let's do that. So we get 1 over 4 times 1 over, now tangent square is going to be secant squared theta over cosine squared theta. And then secant is 1 over cosine theta. And then d theta. So we then divide. So division basically means you flip. You take 1 divided by sine squared theta over cosine squared theta. It's going to be cosine squared theta over sine squared theta. And then times 1 over cosine theta d theta. So now we can go and simplify. So we simplify 1 cosine, and that gives us 1 over 4 times cosine theta over sine squared theta d theta. Now when you look at this integral, then we go back to calculus 1. We know we can solve this by using u substitution. So if we let u be sine theta, then a du is going to be cosine theta d theta. So then we get 1 over 4 times 1 over, since u is a sine theta, so you get over u squared, and then cosine theta d theta is what we call du. So to solve this, to integrate, we'll have to move this we have to move 1 u squared to the numerator, which means we're going to have a change of exponent from positive to negative, and then after that we can integrate. So when we integrate u to the negative 2, we're going to get u to the negative 2 plus 1 over minus 2 plus 1 plus c. So simplify, we're going to get minus 1 over 4 times u plus c. And then since u is, we know u, we use u here to be sine theta, so we can go and replace u with sine theta. But then we have this, we have 1 over sine theta. So 1 over sine theta equals 2 cosecant theta. So we're going to get negative 1 over 4 times cosecant theta plus c. Now, what is cosecant? So we go back to the right triangle. Okay, so we go back here. We see that since this is our right triangle, so to find cosecant theta, we know by definition it's basically hypotenuse over opposite. So which is x squared plus 4 square root of that divided by the opposite side, which is x. So it's going to be square root of x squared plus 4 all divided by x. Let me copy this down here. So we end up with 1 over 4. Okay, actually, so negative 1 over 4 times the square root of x squared plus 4 and all divided by x and then plus c. So we get our answer. Thank you.